A desk clock hushes at the edge of the room, and the walls learn to breathe again. Outside, the city dims to a scatter of quiet windows. Inside, the light from your screen turns gentle, the way starlight softens when it crosses a long distance. We are unhurried tonight. We're going to travel without moving, letting the mind stroll while the body loosens its grip. If it's comfortable, lower the brightness a notch. Put your phone on Do Not Disturb. Slip on headphones so the world narrows to a calm corridor of sound. Midway through, when you're drifting, there's a sleepy science playlist waiting to carry you farther. You don't need to remember it now. Your only job is to listen, and perhaps to let a few thoughts pass like faint satellites crossing a quiet field. I'll speak softly, steady as a metronome that has decided to be kind. The voice you hear belongs to a patient observer who has watched many nights like this, who has made peace with the long arc of data, and with answers that arrive the way dawn does, gradually, then all at once. We'll keep one thread of light between us, a slim guide rope from your room to the deep sky, and we'll follow it with small steps. If sleep comes early, let it. The story will keep going without you, and that is part of the design. If you stay awake, let the details settle like dust in a sunbeam, unforced and easy. We'll begin with a visitor far from the sun, where a faint halo tells a larger tale, and a quiet puzzle asks politely to be heard. We begin. Let your eyes move with me, slowly, across a faint bloom of light. It sits far from the sun, not dazzling, not dramatic, just a pale halo that thickens toward a dim core and thins again into velvet dark. I trace the edge the way a fingertip follows a window's cool rim, and the glow answers with patience. What looks quiet from here is busy at its center. A visitor at almost 3 times Earth's distance carries a sheen that should be modest at this range, and yet the halo holds, as if lit from within by a soft resolve. We do not rush that thought, we simply follow the light. Tonight's story begins with ultraviolet photons and a careful stack of exposures. Astronomers pointed a fast, faithful observatory toward the halo and listened for a whisper at a specific wavelength where broken water shows itself. Hydroxyl is the name for that trace, a luminous breadcrumb sunlight leaves when it tears water apart. To catch it, the team layered image upon image for hours, coaxing signal out of noise until a curve rose clean enough to trust. The number that arrived is not a shout, it is a steady count, like rain on a distant roof. Roughly 40 kilograms of water each second, escaping into space at a distance where you'd expect a fraction of that. Step a little closer, still with your eyes. At 2.9 astronomical units, sunlight is gentle, a third of what warms Earth. Ice normally sighs there, it doesn't boil away. If we picture the nucleus as a dark, lumpy sphere 5 or 6 kilometers across, the arithmetic of heating suggests a modest, patchy activity. Little vents where the morning sun finds shallow ice. Models of such comets often settle near a few % of the surface doing the work. And yet, when we let the halo tell its own story, the implied active area nudges high. A quiet nudge, but real. The answer may live not on the surface, but in the light itself, in what that light hides. Near-infrared eyes at big telescopes have hinted at something suspended in the halo. Not only vapor and dust, but shards of ice, small and scattered. Each fragment, once exposed today, warms quickly because it is tiny. Heat runs through it fast. Surface area dominates over mass, and that simple geometry turns the shard into a miniature vent. Hundreds of little suns in the sense of warm patches, not blazing stars, each one raising a wisp of water that joins the broader glow. You add them together, and the halo looks fuller than a bare nucleus could supply on its own. A short pause here. Let the room settle. Hear the near-silent fan, the faint tick somewhere behind you, the even breath that says the body knows what to do without being told. The screen's light cools a shade, and the mind moves the way a moonbeam crosses a floor. Not fast, not slow, simply steady. We come back to the halo with kinder expectations. If 8% or a touch more is active, that is not defiance. It is architecture. You can imagine crusted areas giving way where sunlight pries at flaws, the plume rising and joining others, the brightness adding like calm voices in a dark auditorium. The energy ledger remains honest. What seemed too expensive for a single surface becomes affordable when the light reveals a crowd of small contributors drifting near the core. The fragments need not survive long. They only need to exist briefly, heat up and exhale before radiation pressure and gentle collisions erase their individuality into the larger field. From this distance, our senses are servants of patience. Hydroxyl is not water, it is a consequence, and reading consequence backwards to cause is an art of limits. That is why observers stacked exposures for so long, why numbers were massaged carefully, why the phrasing stayed modest even as the count held steady over the observing window, because the halo's story deserves plain words and unhurried cadence, not a flourish. In that restraint, another kind of brightness appears, the brightness of knowing where certainty ends and where careful inference begins, which, when you are trying to fall asleep and learn at the same time, is a very comfortable pillow. There is a pleasant symmetry in the picture that emerges. A nucleus turning slowly, a thin skin warming and sighing, a crowd of ice chips nearby acting as amplifiers of sunlight, a halo that thickens just enough to surprise the models at this range, but not enough to demand new physics. And beneath it all, the calm arithmetic of distance, energy, and area, telling us that light, when it finds more surface to touch, will draw out more breath from frozen stone than the surface alone could manage, even at a place where the sun's warmth is more suggestion than command. You can let your gaze soften now, if it hasn't already. The halo thins toward a cooler blue in the mind's eye, the core dims a shade, and the field around it becomes a softer night. That is where we leave this scene, in a gentle dissolve of light into light, the way twilight forgets itself and becomes evening. The instrument keeps time for us. The shutter opens, a breath. The shutter closes, a breath. And between those two soft clicks, the sky lays down another thin layer of signal. I sit inside that rhythm the way a listener sits inside a metronome, and the data arrive as quiet beats more than numbers. Exposure, readout, nudge the pointing. Exposure again. The cadence is unhurried on purpose, so the faintest glow can rise above the room's own murmur. Somewhere in the electronics, a fan carries heat away, with a whisper like a distant tide that never breaks. In the headphones, the spectrograph hums a steady line. We are listening to a comet, one beat at a time. Infrared eyes respond differently than ultraviolet ears, but both keep the tempo. Ultraviolet stacks told us that sunlight was breaking water, leaving a spectral breadcrumb we could count. Now, near-infrared channels lean toward solids and ices, toward the way light scatters from surfaces rather than from gas alone. Frame after frame, the field resolves as a smooth blur, then a slightly pebbled blur, then a blur with tiny inclinations toward structure, as if the halo carries seeds of brightness that are not lines from jets but dots from pieces. We do not claim more than we have. We say that hints exist, that the coma is not only vapor and dust, that some of the light behaves as if it is bouncing from small cold faces adrift around the core. Here is the gentle physics behind that hint. A large surface warms slowly, because heat must travel inward through more material. A small surface warms quickly, because there's very little interior to buffer it. Engineers call it surface area to volume ratio, but tonight we can think of it as the difference between heat in a kettle and warm in a raindrop on your palm. Even at 2.9 astronomical units, even under mild sunlight, a chip of ice the size of a sugar cube can reach equilibrium quickly, then sublimate on all sides. The process is not dramatic. It is a soft hiss more than a spray, a steady release measured in grams per hour per shard, multiplied by many shards. The sound of it, in our chosen metaphor, is the sound of many tiny vents sighing in time. Traditional comet pictures favor jets, and jets do occur. Vents on the nucleus open where the sun pries and the rotation carries day into night and back again. They throw gas and grains in plumes that can be mapped, that sometimes arc like faint handwriting across the coma. But a field of fragments writes differently. Distributed sources turn the handwriting into a chorus of dots. The halo brightens more evenly, the gradients soften, and the center-to-edge slope looks fuller than a handful of jets alone would sculpt. In stacked images, that fullness appears as a barely perceptible thickening on the sunward side and a gentler fall-off downwind. No single line shouts its presence. The pattern speaks in harmony. When you hear 40 kilograms a second, you might imagine a continuous pipe. The mind likes clean plumbing. The instrument invites you to think in totals, then in parts. If a single chip were losing, say, 1/10 of a gram a second under this sunlight, it would take hundreds of thousands to carry the whole song. That number sounds large until you consider the volume of the inner coma and the churn created by gas drag, lifting fresh material from the surface, and by micro-collisions that keep splitting larger lumps into modest shards. They need not last long. A few minutes to an hour at a time is enough. Sublimation smooths them, shrinks them, and when they become dust, radiation pressure takes over and the soft chorus moves outward while new voices rise near the core. Gas drag, gravity, and sunlight share the stage. Gravity from a 5 to 6 kilometer nucleus is slight. A person could leave such a world with a well-timed leap, and a sugar cube of ice rises easily when gas escaping through nearby pores pushes on it. Once aloft, the shard feels the sun in two ways. Its surface warms and turns to vapor, and the light itself pushes very gently, more efficiently on smaller, lower mass grains than on compact lumps. There is a sweet region where fragments are big enough to survive minutes of heating, but small enough to be shepherded outward, so they do not simply fall back. The instrument does not see the shepherding. It hears the effect as a smoothening of the brightness profile, a quieting of sharp features into a rounder tone. let a long breath fall in the room. The hum holds steady, the tick returns, and your shoulder blades loosen by a measure you don't have to quantify. The mind can picture one frame in which the coma is nourished from inside by jets and from around by drifting chips, and another frame in which those chips have thinned and the jets regain their solo lines, and another in which a fresh peel from the surface births 100 more fragments that pulse the halo brighter again. In such a progression, which plays out hour by hour and night by night, the water we infer from ultraviolet whispering, and the solids we suspect from infrared glints join as a single score, whose dynamics are set not by one loud instrument, but by many small ones, each adding a little lift to the whole so the total feels stronger than the nucleus alone could sing. Observers do small, careful cross-checks to keep the song honest. If the coma's colour and polarization lean toward larger grains alone, the fragment hypothesis weakens. If they show signatures consistent with fresher ice faces, the case strengthens. If the inner halo brightens faster than a jet geometry would predict when the viewing angle changes only a little, distributed sources become the softer, safer explanation. In the logs, these show up as annotated curves and cautious sentences. In a sleepy room, they land as reassurance that no one is rushing to call anomaly where a familiar mechanism sung by many voices will do. The patience to let multiple instruments agree is one of the quiet disciplines that make this work feel humane. The last measure tonight belongs to the telescopes that listened for these faint percussive hints. Gemini South watching through dry air, the infrared facility at Mauna Kea keeping the beat through long, even exposures. Each device tuned for a particular register, and all of them together turning distance into something we can hear with our minds as a consistent tone. Their logs do not use lullabies, but what they record behaves like one. A slow, repeating pattern of light scattering from small faces, humming in phase with the hydroxyl counts from ultraviolet work, and keeping time with a comet that is not loud or unruly, but steady. Steady enough that a listener who wants to rest can let the rhythm carry them without needing to hold a single number in hand, because the cadence is the message, and the message is that many small sounds make a single calm ring. The recorder clicks once. What do we do when the road bends out of sight behind the sun? We keep walking by the map, not by the view. The comet rounds a corner called solar conjunction, and from Earth, the glare closes the trail. Telescopes that love darkness cannot step into daylight without harm, so we let geometry take the lead. A visitor headed inward is there, still moving, still breathing out gas and dust, but the mile marker is hidden by the brightest landmark we know. Conjunction is a simple turn with patient consequences. Draw a line from you to the sun and another from the sun to the comet. When those lines stack nearly straight, the sky around that direction becomes flooded, and ground observatories must look away. Even space telescopes carry safety circles around the star, exclusion angles that keep optics healthy. In that arrangement, October 29th is a date on the chart. Perihelion at roughly 1.36 astronomical units, a close approach not to us, but to the sun, the tightest bend of this passage, taken behind the glare. What happens there? The same steady physics that govern every such turn. Solar energy rises as distance falls, and ices answer. Water warms toward faster sublimation. carbon dioxide, which leaves its solid phase at lower temperatures, can surge earlier and stronger. Carbon monoxide joins if it is present near the surface. Pressure finds cracks, vents open, grains lift, the halo swells, and the tail stretches along the path like a dust-laid ribbon. None of this requires drama. It only requires sunlight and time. But we do not watch it directly this week. Coronagraphs designed to block the sun might catch a slip of the story if the brightness grows enough, and if the path crosses their sensitive fields. Yet, predictions say the visitor is likely too faint and too far from the solar edge for those eyes to tell us much. So we take a traveler's approach. Note the waypoint, imagine the conditions, and prepare to read the next landmark when the path opens again. There is comfort in the before and after. We have measurements from August and early October, production rates inferred from ultraviolet traces, hints of fragments in the inner halo, slow rotation, a coma that seemed fuller than simple jet models alone would demand at that distance. After the bend, when elongation grows and twilight allows careful looks again, we will meet the same object under warmer skin. If activity has risen, brightness will answer. If fragmentation happened, multiple condensations may share the frame. If the nucleus stayed calm, we will find a halo that reflects that calm, only larger from recent heat. All of these are ordinary outcomes on a long road. Take a moment to stand still at the rest point. Let the room quiet itself. The house settles. Distant traffic thins. Your breath finds a route that no longer zigzags. The chair beneath you explains in its own language where you are. Your shoulders listen and release. A faint warmth lives on your cheeks from the screen's light, but the mind cools as if stepping into shade. We are not waiting for a grand reveal. We are keeping pace with an object that moves whether or not we watch it. And there is a strange, generous relief in accepting that the universe does not need our attention to do what it does. Think of the path not as a cliff edge, but as a tunnel with a known exit. We have the ephemerides. The curve is calculated and smooth. Velocity and distance forecast the milestones. When the comet clears the sun by enough degrees for cautious observing, large mirrors will reacquire the track, and smaller ones under dark skies will join as the geometry improves. Spectrographs will look for how the balance of gases changed across the bend. Images will look for how the dust flow reshaped the halo and the tail. Timing will tell us whether the nucleus kept turning as before. And somewhere in the rhythm of those nights, patient sentences will begin to form. The kind with commas that breathe, the kind that say, we saw, then we saw again, and between those two seeing we learned. Which is the quiet literature of travel written by instruments that never hurry. It is worth remembering that a bend this close to the sun is not a threat to a body at this distance from Earth. It is a season for the object itself. Thermal stresses rise and fall with the day-night cycle. Internal pressure explores old paths in the ice, and grains that have waited a long while for warmth finally lift and drift down the lane. On the far side of the turn, cooling begins again, and the road straightens toward outbound space, where activity softens step by step in a pace set not by will, but by inverse squares and gradually lengthening days. In that soft geometry, a long sentence about patience fits, because the only thing asked of us is to stay with the map and accept that, like any journey through bright country, there are stretches where you look down at your boots and listen to the guide count the steps, and stretches where the view returns. And both kinds of miles belong to the same walk across the same ground. When the view returns, what shall we greet first? The brighter halo, the longer tail, or simply the comfort of seeing the traveller come back into open sky? August 6 lives on my desk like a postcard from far water. The image border is quiet, the note on the back simple. NIAR Spec watched our traveller from 332 astronomical units, and the spectrum returned with a tide of carbon dioxide leading the way. In the near-infrared, two shorelines matter most tonight. The water band near 2.7 micrometers, and the carbon dioxide band near 4.3. And the latter rose higher, broader, more certain. The ratio folds into the card like a short sentence. Roughly 7 to 8 parts CO2 for 1 part H₂O. We set the postcard beside earlier notes and breathe. This is not a storm. It is a current. Imagine a small vessel easing out from harbour at dawn. The channel is familiar, but the tide runs stronger than memory, pulling the keel in a direction the charts rarely show. That is how the spectrum feels. Expected lines in expected places. Yet, the balance leans toward a current we do not sail every day. Water is present, steady, even bright in patches. But the carbon dioxide run is the one that carries most of the light, and the wake behind that choice spreads farther across the frame. The traveller is not water-led tonight, but CO2-led. And we note the set of that flow without alarm. Across the postcard's face, detail blooms when you lean closer. The water emission shows texture, as if springs open in discrete coves, brighter knots within the inner coma, not a smooth sheet. The CO2 signal, by contrast, reads as a broader channel, spread more evenly across the sunward face. If the nucleus holds mixed layers, this is how such a mix would declare itself. Carbon dioxide ice common near the surface, water ice peeking out in pockets or arriving from icy debris adrift nearby. The vessel's wake looks smooth from a distance, but look into it, and you'll find braided threads. Let the room move into the same slow sea. You can hear the faint susurrus of a fan, maybe the smallest creak of wood settling, the breath in your own chest finding a longer cadence that matches an imagined swell. Nothing in the room demands. Everything floats. The eyes rest on the postcard again, and the numbers feel less like verdicts and more like wave heights called by a steady voice from the bow. Two main routes can deliver such a tide. One is ancient weathering, a body travelling through stellar neighbourhoods and interstellar quiet for eons, its outer layers worked by cosmic rays and ultraviolet light until water bonds break more easily than carbon-oxygen bonds. Hydrogen drifts away, and what remains rebonds into carbon dioxide ice in the topmost meters. The other route begins at birth, a formation zone cold and carbon-rich, beyond a line in the young disk where carbon dioxide freezes readily, while water ice is scarcer, so the object accrues more CO2 grain by grain as it grows. Either path yields a hull whose upper planks carry more carbon dioxide than the decks below. The first paints a gradient with depth, the second lays a blueprint into every layer, and the spectrum in our hands asks which story the vessel prefers. A small clue hides in the smoothness of the CO2 glow. Uniformity fits a widespread surface reservoir warmed by the sun. Patchiness in water fits vents or fragments offering localized springs. If so, we might be seeing carbon dioxide as the broad tide and water as the harbour freshet, both part of the same sea, yet arriving with different textures at the shoreline of our instrument. There is also the comfort of isotopes. Carbon-12 and carbon-13 show a ratio that sits within the familiar range we know from our neighborhood, which says the atoms themselves are not exotic. Only the mixing and the journey gave us this balance. The keel remains wood and iron. It is the current that runs different. Across other ledgers, the pattern echoes. Infrared surveys with wider views reported a great CO2 envelope extending farther than water could be traced at comparable sensitivity, while ultraviolet instruments listening for hydroxyl, the fragment sunlight leaves when water breaks, heard a quieter but persistent murmur. Glue those cards together, and the picture that emerges is not of a vessel sailing against the laws of the sea, but of one travelling in a region where an easy-flowing carbon dioxide current carries most of the motion, while water moves in eddies and inlets. And because our maps are built from rivers closer to home, we feel the difference like an unfamiliar pull on the rudder, rather than as danger, which is a helpful way to steer through uncertainty when the night is long and the room is kind. If this is processing, then perihelion is the moment when the topmost CO2-rich planks warm and vent first, peeling back to reveal deeper, wetter timber. If it is formation, then even as the sun lifts activity, the ratio may hold, because the recipe is uniform throughout. Either way, the science is unhurried. The instruments after the bend will compare maps, looking for whether the water patches grow larger and more numerous, or whether the smooth CO2 sheet keeps owning the inner face. And that choice, evolution toward water-led behavior or persistence of CO2 leadership, will be one of those quiet waypoints that tells us more about where this traveller learned to sail than any single number could, because a ratio in isolation is a snapshot, while a ratio watched across a changing tide becomes a story with beginning, middle, and end. There is a temptation to read habitability into the mix, to equate a carbon-forward tide with dry worlds and a water-forward tide with friendly shores, yet that leap runs faster than the boat. Comets are messengers, not maps of whole coasts. They carry local weather from particular coves of their birth disks and scars from long voyages afterward. What we can say, gently, is that a CO2-led spectrum asks us to widen our catalogue of climates in which icy bodies assemble, to admit that the galaxy stocks many pantries, some with more carbon on the top shelf and some with more water, and that both kitchens can produce travellers who make it here, with their cargo mostly intact. The sea is broad. There are many currents. Our harbour is only one among thousands. I turn the postcard back over and write a single line for future me to find when the data from farther along arrive. It reads like this. CO2 runs strong tonight. Water joins in islands. Watch whether the islands grow. The ink dries in air that smells faintly of dust and quiet plastic, and I slide the card under the corner of a keyboard, where it will wait like a folded chart, ready to be tested against the next tide that rises from the same hull on the other side of the sun, at the time marked in the margin when we expect to see the shoreline again. At 02:14, the tide mark holds. The room settles into a hush you can feel along the floorboards. A low fan smooths the air like a palm over linen. Far away, machines pass behind Mars and turn their faces to the dark, and the sound you would hear, if space carried sound, would be the soft clack of shutters and the faintest electrical murmur, a loom working at night. we listen instead to what their images imply, the way thread implies cloth. From October 1st through the 7th, one orbiter above the red planet pivoted its camera and began to stitch. Each exposure lasted the span of a slow breath, multiplied many times over, 3 minutes per frame, tracking the visitor so carefully that the stars slid into streaks while the comet stayed centered like a knot in fabric. The result was not grand art. It was useful cloth. A fuzzy core, a gauzy halo several thousand kilometers across, and no extra knots tugged free from the weave. At roughly 29 to 30 million kilometers from Mars, even the best. Thread count could not tease out the nucleus itself. What we saw was the garment around it. The older orbiter tried, too, tilting instruments that prefer rocks and frost toward a dim smudge in a vast sky. Its weft and warp weren't cut for this, and the signal fell through the gaps. Still, the attempt matters. When you sew by feel, you learn where the fabric grips and where it gives. Here the cloth gave. The smudge slipped past unmeasured, and that, too, is a kind of measure. If you're picturing razor detail, trade that for the texture of muslin. The best theoretical resolution from a powerful camera at that geometry would turn a 5 to 6 kilometer nucleus into a sub-pixel sparkle. One bright stitch in a field of soft fiber. Processing takes time, the way drying takes time for a hand-washed shirt. Data queue, calibrate, pass through pipelines. Weeks, sometimes months, before a public release threads its way to daylight. That delay is ordinary. It is the air between stitches, not a hidden seam. What the images did show carries a small, calm surprise. Modelers expected an inner veil 2,000 to 3,000 kilometers wide under that sunlight at that distance, a modest shawl around the core. The frames from Mars suggest 4,000 to 5,000. Coma sizes are hard to hem cleanly. Exposure length, background scatter, and where one decides the cloth ends and the night begins can add or subtract a great deal. Yet, even with those caveats, the garment looked fuller than the first pattern predicted. One gentle reason fits the earlier pages in our notebook. A field of icy chips adrift in the inner coma adds surface for sunlight to work, and many small faces exhale more than one large one can, so the weave thickens without demanding more from the nucleus than it can honestly give. Alongside the images, a spectrometer aboard the same orbiter listened through the glare and the thin Martian day for any hint of composition. The device was built for atmospheric threads, trace gases over Mars, but it can, with patience, catch the faint dye of molecules in a passing coma. The signal to noise was low, as expected. Lines blur when woven into such a coarse fabric of light. The team will work those threads for months, tugging gently at artifacts, unpicking scattered sunlight. And if a real color holds, a CO2 band here, a water-related line there, it will be another patch sewn to our growing quilt from a vantage unlike any other. If not, the cloth remains honest about its limits. On the ground of Mars itself, there were moments when cameras pointed up. The rover's zoom eyes, made for stones and dust devils, swept the sky between tasks. Later, hands on Earth stacked frames and whispered that a faint streak lay where calculations said the comet should be. It might have been a cosmic ray tapping the detector. It might have been compression artifacts drifting like lint. Or it might have been the thinnest filament from the visitor's veil barely caught and already fading. We file that with the kinder speculations and let it rest. The cloth of proof is thicker than a single strand. More than anything, the Mars week was rehearsal. It asked the orbiters to retune their looms, track a moving target, hold a long exposure without tearing the frame, coordinate slews and timing with other instruments so the whole bolt of night could be used well. They did. The comet threaded the field center across nights, the cadence held, and the ephemerides proved themselves on a stage far from Earth. Those habits travel forward. When post-conjunction nights arrive and other spacecraft and ground telescopes begin their own long weaving sessions, the Mars cloth will be the reference swatch we keep touching, a reminder of how the pattern behaves when the light is thin, the angles awkward, and the hands still steady. Stand in the room for a breath. Feel how the air moves across your sleeves. Imagine the coma not as smoke, but as gauze, fibers of ice and dust joined by gas, tugged sunward into a soft apron and draped along the orbit into a trailing hem. If fragments contribute, the gauze thickens close to the bodice and thins where the weave gives way to freer thread. If fragments fade, the structure returns to the cleaner cut of nucleus-fed jets, and the inner cloth looks more tailored. Either way, the garment speaks in drape and fall, and our cameras read drape better than they read stitches. A very long sentence belongs here, uncoiling like a selvage. The value of this quiet cloth is not that it dazzled, but that it proved the fabric holds together under stress, pointing, tracking, integrating, calibrating, so that when the brighter bolts arrive after perihelion, and when composition maps ask to be overlaid on brightness maps, and when analysts reach for the seam ripper to separate what the nucleus wove from what the drifting chips added, the hand already knows the pressure to use and the rhythm to keep, because it learned those motions on a week of coarse weave that asked for patience and paid it back in confidence. Let the last half minute be all texture. Air smoothing across a grill, the soft fold of clothing as you settle deeper into your chair, the distant hush that feels like a room, remembering its stitches, while a small white dot far beyond Mars carries its own garment through sunlight, its hem a little wider than we guessed, its pattern still being learned, the loom running, the shuttle passing and returning again, begin close. A thin line in shadow brightens, not with light, but with vapor. Mist lifting where dawn has just touched a ridge on the nucleus. The fracture is hairline, a breath-width seam, and when day creeps over it, the sealed cold inside meets the softer heat outside and exhales. You can imagine that plume like fog over a river at first light. Quiet, pale, unhurried. Around it, frost grains glint and vanish. Small things happen first. Step back a pace. Thermal gradients write invisible stress through any brittle body. On this traveller, a 5 to 6 kilometre mass stitched loosely by ice and dust, the sunward face warms while the night side keeps its chill. Between them, material expands and resists, then yields. Gas that was locked in pores feels a path reopen and presses outward. Grains that were resting lift as if the mist itself had hands. None of this requires violence. It is the slow weathering of a thing that has slept cold for ages and now finds itself near a star again. Stories of breaking are part of comet lore, told softly, not to alarm, but to teach. One body wandered near Jupiter in the early 90s and felt tides pull it into a string of pearls long before cameras on Earth watched those pearls fall into the planet's clouds. Another, circled by our calendars as 73P, shed pieces in the mid-90s, and again a decade later, like a brittle log giving splinters at each turn. A third, discovered late in 2019, seemed to promise a show before it faded into a loose haze and was gone by spring. Those are precedents, not omens. They remind us how ice and dust can separate under stress, and how the sky records the unbinding as a sequence of gentle blurs instead of explosions. Return to this object's present steadiness. Photometry suggests a rotation near 16 hours and change, a pace that is neither hurried nor slack. At that rate, centrifugal tug is modest. Gravity, slight but present, still gathers the surface to itself. If vents sit in balanced latitudes, if gas leaves in patterns that pull equally left and right over a turn, the torques cancel and the spin stays calm. When outgassing is symmetric enough, it behaves like a relief valve. Pressure leaves without twisting the body faster, and cracks that do form sigh rather than shout. In such a regime, mist rises, and the shape holds. How would a breakup look if it came? First, light would step up, not with drama, but with the simple math of surface area. More faces catch the sun, more mist lifts, and the halo grows brighter than the model that assumed one piece would allow. Then, after that brief swell, the brightness may settle, or even fall, as fragments drift apart, and the light they throw spreads wider. Images would stop showing a single soft peak and start showing 2 or 3, each a small concentration along the orbit, like dewdrops separating on a wire. Tails would fork, dust would thread thin lanes, the inner coma would lose its roundness. Instruments would measure the offsets night by night, and the offsets would match nothing more mysterious than the speeds at which the pieces left one another. That is the signature of a natural untying, motion that gravity and the earlier push of gas can account for without remainder. There is also the longer view, and it is gentler than fear. An intact nucleus gives us a cleaner core sample of composition, density, and structure. A fragmented one trades that clarity for a different gift, slices through internal layers we could never see otherwise, faint windows into how chemistry varies with depth. Scientists take both outcomes seriously and sleep well under either sky, because the learning continues either way, and the object is not a threat regardless. It is only an old cold traveller finishing a warm curve and then cooling again. The work is to read what it writes, not to worry. A slow, long sentence can hold the whole path. A crack finds its way through regolith and ice, where morning meets night. Mist lifts and carries a few grains that nudge a nearby chip loose. The chip rises and sublimates and becomes smaller as it drifts. Another crack opens and closes with the turning day. Pressure chooses older channels because they cost less to clear. And over hours or days, the surface surrenders curls from its edges, until either the body sighs intact through perihelion and out again, or a seam gives enough for pieces to separate into a beaded haze that follows the same highway, each bead breathing in its own small way as it goes. What steadies the hand tonight is the sum of quiet indicators. The rotation period is stable. The light curve lacks the nervous ticks of a body being torqued hard by lopsided jets. Pre-conjunction images show no second peak resolved at Mars. None of these guarantee integrity through the warmest mile, and none foretell failure. They are simply pieces of mist you hold up to the light and describe honestly. After the sun bend, observers will weigh them against the new scene. If the halo is rounder and brighter, that is warmth doing what warmth does. If the halo has twins spaced along the path, that is separation behaving like nature's arithmetic. Either way, the cadence of watching does not change. We count, compare, and repeat until the pattern is clear enough to sleep beside. Let the room cool by a degree. The idea here is not to brace for fracture, nor to cling to wholeness, but to be ready for what the mist shows next. Plumes in their old places, or small new condensations blinking into being where a seam let go, with motion that matches the map we would write for drifting pieces, and with no need for any extra push beyond the one the sun and the body already share. And if the speed is high and the path cuts steeply across our neighborhood, then the origin likely comes from older lanes of the galaxy, where traffic moves differently. If the arc rises above the thin stellar highway and dives back through it, then the traveler belongs to a population that lives with height as well as length. If the numbers hold, 58 to 60 kilometers each second in the galactic frame, with a strong step in the up-down direction, then the map points toward the thick disk, that older, quieter ring that brackets the one we know best. I keep the picture small at first. A single object glides on a long arc that ignores the grid of local motion, crossing the sun's neighborhood on its own schedule. We measure velocity components the way hikers measure slope: forward, side, and rise. The rise is the telling part here, a vertical stride that marks bodies born when the Milky Way's lanes were rougher and less settled. Kinematic fingerprints are gentle things. They do not shout. But this one taps the page and says, "Look at the higher road." If you step back from one object to the cohort it gestures toward, the scenery changes. The thick disk is a memory more than a place. Stars older on average, metals fewer by a notch, orbits that bob above and below the midplane like long rollers. Those orbits speak of times when the galaxy had not yet flattened into today's careful swirl. In that era, planet-forming disks still spun, debris still scattered, and comets like this one could be thrown free with the same easy mathematics that works now. Only the launch pads were older and the inclinations steeper. A traveler ejected then would spend billions of years between mileposts. To test a story like that, we run the arc backward. Astronomers take present position and motion and integrate across 10 million years of star fields, whose routes we know from a precise catalogue of distances and drifts. The goal is simple: find close passes that could have turned the wheel and sent the traveller our way more recently. The result in hand is the quiet kind of answer. There are encounters, but not ones that wrench the path decisively. No recent shove explains the present crossing. The implication is not drama. It is endurance. The arc we see has been the arc for a long time. Let the room provide the middle mile. The air evens out. A faint pad of sound settles under everything, like a road that no longer needs attention. Your eyelids learn to idle. The shoulders lighten by a notch. The clock forgets to hurry. We stay with the long arc the way night drivers stay with lane lines. Soft focus, steady hands, no strain. Time at this scale does work on a body, but it works from the outside in and only so far. Cosmic rays and ultraviolet light act like weather along an empty road. They sand the paint, not the frame. In ice and dust, that weather can rearrange chemistry in the first meters or tens of meters, making outer layers lean differently than the core. Deeper down, the kilometers stay what they were, a record of the first miles after launch. That is the quiet hope here. When we read gases given off now, we are sampling a surface edited by the journey. When we interpret ratios that do not budge with changing sunlight, we may be hearing from deeper pages that still say how and where the traveler started. The galaxy's vertical rhythm adds its own kind of punctuation. Up through the disk, out toward thinner neighborhoods with fewer particles to strike, down through the disk again, where the traffic is busy and the sandblasting goes a little faster. Then up once more. Each swing takes tens of millions of years. Each crossing is another gentle coat of travel dust, another round of tiny impacts and energy nicks that slowly teach the skin to look older than the bones. The interior, protected by length and by time, keeps its accent. Stand at the edge of a wider map for a paragraph, and let a long sentence make room for what comes next. If this one arc points back toward the galaxy's older lanes, and if the instruments we are building now, surveys that will walk the whole sky every few nights and catch faint movers earlier, begin to collect dozens more crossings each year, then the notebook will stop being a diary of rare visitors and become a road atlas of interstellar debris, with coloured pencil lines for objects from the thin disk, for objects from the thick disk, for a very few from stranger interloping paths, and with little annotations where chemistry and motion agree, so that over seasons of patient plotting we learn not only where such travellers go, but where they most often begin, and how the galaxy has been scattering and mixing its small cold messengers across ages longer than any story we tell in a single night. The sample is still small, and the mind is good at making patterns from a handful of mile markers. Caution is part of the drive. One object carried little water and much argument. Another was more ordinary and carbon-rich. This one leans toward carbon dioxide and carries an older gate. 3 points do not give a highway code, but they suggest the lanes are varied, and that variety is itself a fact worth sleeping beside. The next arcs will help us shade the picture properly. To keep the scale humane, I return to a simple image. A single traveller moves on a long arc. It has crossed more neighbourhoods than we can name. Its coat has been worn by the road, but its core still remembers the first turn. We meet it for a moment, learn what we can about the pace and the start, and then watch it continue. Along the way we improve our maps, and our questions become kinder, because they fit the length of the road rather than trying to outrun it. That is enough for tonight. 3 quiet threads will hold our place while the rest of the cloth settles. Thread 1. Infrared eyes see nothing warmer than a sunlit, dust-coated ice. Thread 2. The path fits gravity with the small nudges expected from ordinary outgassing. Thread 3. The spectrum carries familiar molecules: water, carbon dioxide, carbon monoxide, in lines we have learned to read. With those threads between thumb and forefinger, the fabric does not slip. Let the room contribute a low weave. Air moves along the nearest wall like a hem being pressed. The desk gives a small, dry creak. A distant appliance lays down a soft, even band of sound. There is no need to name the machines. The hush is enough to remind us that signal lives best where noise is known, and that a calm background is as much a tool as any lens. Thread 1 is the warmth thread. Every working device radiates heat, and every warmed surface does the same. If a comet carried something busier than sunlight and ice, electronics, or active engines, it would pay for that work with glow, and the glow would slide into wavelengths where our instruments keep vigil. Observers checked the usual places in the infrared and found emission consistent with the cold surface grains of dust warmed by the sun, not with waste heat from hidden work. The fit is not dramatic, it is tidy. Temperature curves match a body that accepts light and irradiates it without extra power in the ledger. The cloth here feels tightly woven without snags. Thread 2 is the motion thread. Take positions night after night, across weeks, and plot them against the pull of the sun. Include the small, expected shoves from gas leaving the surface, and the points meet the curve without complaint. No sudden kinks, no unexplained bends, no accelerations that refuse to fit inside the boundaries outgassing can draw. This is not heroism, it is bookkeeping. Astronomers like books that balance because they let us sleep. If the path were troubled, if turns arrived where no turns should be, telescopes would pivot and pencils would sharpen, but the path is not troubled tonight. The seam is straight, the stitch length even. Thread 3 is the chemistry thread. Spectra are portraits made of lines instead of edges, each line a colour that belongs to a molecule that can glow or scatter or break in sunlight. Water shows in its way, carbon dioxide in another, carbon monoxide in a third. All of them appear in proportions that tell a story different from our most common comets, but not a story made of stranger's ink. The lines sit where we expect them to sit. They rise and fall within ranges our catalogue already knows. And when early observations were faint and messy, later ones with stronger signal brought those lines into focus instead of erasing them. That is how a fabric goes from sketch to cloth. Threads that looked loose tighten under a second pass. It is fair to ask what would have tugged the cloth if something unusual were woven in. Excess heat beyond sunlight's gift, motions that refuse the simplest forces, lines in the spectrum that demand unfamiliar chemistry, or missing lines where standard ones should appear even in deep exposures. Those would not be definitive by themselves, but together they would change the hand feel of the whole bolt. Teams looked. They continue to look. Not because doubt is fashionable, but because the best looms test their own tension as they work. A null result is a kind of thread count. It tells you how tightly the fabric has been pulled across the frame. Voices in our field have said this plainly and gently. A senior scientist responsible for small body studies put it with a double very to emphasize the point. This looks like a comet and behaves like a comet. Another, who spends his days asking the most daring questions about life and technology beyond Earth, walked through the anomaly claims point by point and showed how each one thins under better data. Early sizes refined downward as images improved. Early spectral blanks filled when signal grew. Dust patterns that look asymmetric but sit comfortably within the catalogue of jet behaviours. None of this closes doors. It keeps them on their hinges and makes sure the hinges are oiled. Skepticism here is not a wall. It is a seam guide. It lets the stitch line stay straight so the whole piece hangs well, and it saves the cloth for the moment when an edge truly does not match the pattern, because such moments deserve a clean table and a fresh blade. A claim can be extraordinary, but the steps must remain ordinary. Measure, compare, repeat. Ask for signatures that instruments can test. Look for agreement across devices that do not share the same weaknesses. The reward for that discipline is not drama, it is trust. The mind can wander briefly to what would flip these threads. Imagine an inner coma fragment whose track cannot be made to fit any reasonable push from sunlight and gas, a seed that changes course mid-arc in ways our models cannot accommodate. Imagine thermal emission that climbs above the curve even after you account for dust size and color and angle. Imagine a deep integration that fails to find a line which, by every experience with this sort of object, should be there. Those are tug tests a careful tailor uses. If the cloth tears, we stop and ask new questions. If it holds, we keep sewing. Now let a long sentence unroll and soften in the middle, the way a bolt yields under its own weight when two hands carry it from one table to another. The point of these three quiet threads is not to dismiss surprise, or to iron out every wrinkle, but to show how a fabric can be both intricate and honest. Warmth that matches sunlight on dust and ice, motion that follows gravity with modest, modelled deviations, from gas leaving sunlit faces, spectra that write familiar chemical names in steady lines. And how, when those threads run together for weeks and months across multiple looms and shops, the resulting cloth calms the eye enough that if a new stitch appears out of place, it really will be out of place, and not merely an artifact of an untuned frame or a hurried hand. Scientists push back hard when the weave is misread, not because they dislike wonder, but because they love it enough to protect it. When a bolt truly defies the pattern, it deserves all our attention. Until then, we keep the loom slow, we keep the selvage straight, and we build a garment that will wear well in the weather of doubt. Listeners like you live in that weather too, and a steady seam makes good company. We can hold three quiet threads and still leave one hand free for whatever the next night asks us to carry. The three quiet threads return, softer than before. I keep one colour for truth tonight, a pale blue line that runs steady across the page. Around it, other lights flare and fade, scarlet banners promising crisis, amber warnings that multiply in the dark, and the eye can tire from so much flicker. The blue asks less of you. It prefers calm. This so we place it first. Closest approach to Earth is far, on the order of 1.8 astronomical units, a cool distance drawn in that same soft hue, and it stays blue, no matter how many clips insist on red. One rumour was simple and loud. Impact this month. The blue line answered with orbit math that anyone can plot. Positions stepping night by night. Earth here, the traveller there, the gap, broad and unthreatening. Another rumour used the word poison for the tail, as if dust and ions were a stain that could cross the void and settle like smoke. The blue line answered with dilution and distance, and the way sunlight shapes a tail away from the sun, not toward us, like a lamp casting a beam the other direction. Neither answer shouted. Each simply kept its colour. Why do the hotter lights run faster? Platforms reward what pulls the eye. Fear pulls harder than patience. A sentence with siren colours outruns a sentence with evening blue, because our attention is an old creature that startles first and thinks later. But startle fades, and in the quiet that follows, a steady band still helps the mind settle, because it shows where to look next without asking the heart to sprint. A different flare said silence proved secrecy. For a stretch, agency feeds slowed, and a few channels went dim while budgets and bandwidth were sorted. The flicker read, hidden. The blue line read, ordinary delay, the kind you expect when people are furloughed, or when a spacecraft turns its biggest dish into a shade and must speak through a smaller one for a while. Data still flow. They just flow narrower, into queues that take months to clear. February. On the calendar is not a code, it is a pipeline. A faint blue correction can be enough. Closest approach dates are public on ephemerides. Magnitude predictions are posted with uncertainty bands. Telescope schedules are announced weeks ahead. If a dramatic change happens, the alert does not hide in a single corner of the web. It spreads through the same networks that carry the flare, only slower and steadier. When in doubt, check a second calendar that does not blink. The color you want is the one that does not change when you refresh. Let the room hold still for half a minute. The screen cools a shade. The walls forget to echo. Your breathing finds the tempo of a street at 3 a.m. when the traffic lights cycle, through their green and yellow and red with no cars at the intersection. In that hush, the blue line becomes a path you can follow without thinking. Educators and explainers sown across the world turn their own lamps to the same work, trimming glare from claims, placing soft arrows toward primary data, adding one-sentence notes beneath the brightest posts that say, distance is large, tail points away, images pending normal processing, and then stepping back, so the light they add does not become its own glare. That craft is underpaid and undervalued and essential because it keeps night vision intact. It lets you see dim things without being dazzled by the sign next door. Your toolkit can stay small. 1. Keep a bookmark to a simple orbit plotter and watch the geometry change slowly. If a red headline insists on immediacy, compare it with an orbit that barely shifts over days. 2. Favor numbers that name their units and dates. Blue sticks to units. 3. Look for agreement between different kinds of light. Infrared warmth, optical position, radio silence. If all 3 line up with ordinary behavior, they will not turn extraordinary because a caption chose a hotter font. 4. Let the first reading be provisional. Pause before you pass it on. Pale blue is the color of a thought that took one more breath before speaking. Some lights cannot help flashing. An image delayed by a processing queue looks like a missing lamp until you remember how many steps it walks through. Downlink, calibration, archiving, release. A science team typing carefully looks like withholding until you remember how many independent eyes must agree before a sentence can wear the word found. A shut door for a holiday looks like a barricade if you want a barricade. It looks like a shut door if you prefer a nap. And in a long sentence that unspools softly because it wants to make space for rest as much as for clarity, the lesson resolves to this. The sky is blue-black most nights, and the work that reads it uses colours close to that. Quiet contrasts, gentle bands, gradients that reward unhurried vision. And when you choose to see by those tones, the room becomes kinder, the mind less crowded, and the facts have a place to sit down that does not wobble. Return then to the traveller itself. The coma brightened more than some models guessed near Mars, but not by orders of magnitude. The tail, when it grows, will turn away from the sun with the grace of a shadow. Grace is not a red word. The perihelion passed behind glare. Glare breeds speculation. The afterglow will be read in due time by devices that do not sleep and by people who do, and both states are fine. Between now and then, you can let the colours on your screen cool to that same pale blue, the correction that is also a lullaby, because both are gradients that slope toward ease. You can let your shoulders drop here. The sky does, too. We take the slow walk along a quiet deck, shoes soft on planks, one hand on the rail. Ahead, a broad waterline of darkness, and beyond it, the sun, bright enough to bleach detail, so we mind the compass, and not the glare. Off our starboard, a traveller moves on its inward track, and to port, a companion ship holds station, not on any ocean, but in the deep, where a spacecraft can pace a comet from hundreds of thousands of kilometers away and still learn what the eye on Earth cannot. We keep to small steps. The wake we leave is only thought. Early in November, that companion ship, made for icy moons, gives part of its watch to an icy wanderer. Its cameras are named for patience and detail. Janus, to sketch the shape and brightness close in. Magis, to read the warmth and composition in infrared hues. UVS, to listen for the ultraviolet notes of volatile gases. PEP, to feel the breeze of particles and ions where solar wind meets escaping vapor. Instruments wear tidy acronyms, but up close they behave like calm crew. One marks the horizon, one checks the air, one tastes the spray, one measures the current under the keel. Each adds a line to the log. Bandwidth is the tide on this leg. A high-gain dish doubles as a shield when heat must be kept off, and so the words homeward are spoken through a smaller mouth. Pictures and spectra queue like crates in a cool hold, labelled carefully, waiting for clearer lanes ahead. They will reach the docks months after the watch itself, which means we will read November in February, and that requires the kind of patience sailors practice without naming it. The map does not rush, the wake keeps its own time. While the ship keeps watch, shore teams prepare for the first good look from land. As solar elongation widens in late November, large mirrors on night mountains find the visitor in twilight and follow it deeper into dark. Some nights it will be around magnitude 10, other nights nearer 12 or 13, depending on dust and geometry and mood. That range is not a promise. It is a tide table. Small telescopes under honest skies will try. Big ones will take turns at spectrographs and wide-field images, gathering the first afterglow of perihelion into lines and surfaces we can compare to what came before. Think of the tail as a wake over long water. Grain sizes tell you how choppy the engine is below. Finer grains mean vigorous boiling, a lively froth. Coarser grains mean slabs lifting and breaking in quieter pulses. If carbon dioxide still leads, the near-sunward face may show a broad, even sheet. If water opens more vents after insulation peels back, you may see new knots, a pattern of springs within the inner halo. The slow drift of those patterns says as much about layers and pores as any single measure of brightness could. Surprise, if it comes, will not trumpet. It will tap the rail. A second condensation, where only one was forecast, moving in a way that cannot be, bent to any reasonable push from sunlight and gas. Or a brightness rise whose slope demands either a new surface or many new small ones. Most deviations will resolve to ordinary seas, fragments whose motions match the arithmetic of separation, jets whose tilt and rotation phase explain their lean. But a few possibilities deserve close watch, and that is why instruments with different weaknesses take turns on the same water, so that one's doubt can be soothed by another's line. Let the room borrow ship sounds for a minute without making them literal. A steady hush like air over a microphone becomes wind over a bow. A faint fan becomes a distant generator behind a bulkhead. Your own breath keeps time like a bell that has decided to be kind. The screen's glow cools a shade, as if a cloud slid over the sun, and the horizon you're keeping in mind holds even. Parallax is a quiet gift on this voyage. One craft may see a plume just off the limb, while a second, far away, sees the same plume at a different angle. Some nights, two ultraviolet ears can hear the same line rise and judge whether it belongs to a sheet or to a spring. Even when duty cycles and geometry are imperfect, the notes still braid. And the ground adds the third ear, slower, larger, patient as rock. Between them, position and motion and chemistry triangulate like landmarks on a chart, so that a dot of light becomes a place you can point to with more confidence than any single glance would allow. Here is the long sentence worthy of a pilot's log, laid down without haste, and with the lines left wide so you can rest inside them. If the halo grows broader, and the tail deepens, and the bright knots multiply, while the motion remains obedient to gravity, with only the small and modelled deviations that outgassing allows, then we say the sun did what the sun does, and the traveller answered as travellers do. But if the halo shows distinct condensations whose spacing and pace cannot be reconciled with any plausible separation speed or jet torque, or if a fragment turns its bow in midstream without the force to justify it, or if the infrared warmth stays high after you account for dust and angle and colour, then we slow the ship, bring every instrument to bear, and mark the doorway between the seas we know and the ones we must chart anew. For most nights, the seas will be familiar. Janus will bring back frames where the nucleus holds a glow like a lantern in fog. Magis will lay colour over that fog and note where water began to lead or where carbon dioxide kept its hold. UVS will add the thin likes of atoms and radicals, delicately drawn and shy to make claims. PEP will sketch this visible boundary where solar wind slows and curls around the little comet magnetosphere that forms where gas meets charged particles. From those notes, the logbook grows a steady wake, page after page of calm entries that, together, become the map for the next visitor. We do not need grand language to step across this threshold. The work is a walk, not a sprint, a harbour approach, not a race. The door we stand before is simply a change in light, from the glare that hid the bend to the gentler night where detail returns. One hand rests on the frame. The other holds the notebook open to a fresh page. When the sky darkens just enough, we will step through. You and I can sit closer now, as if the microphone has leaned an inch toward your breath. I want you to hear how quiet looks. There is a near silent tone that lives between instruments, the kind a room holds when the last dishwasher cycle ends and the pipes decide to rest. That is the register I'm using, a letter written in sound to say what we listen for and how we know when the listening has found only night. Across oceans and hills, large dishes have already turned their slow shoulders toward this traveller. A white bowl in West Virginia, a field of smaller dishes in California, a great dish in Australia. They have swept through frequencies where people are fond of hiding hope, and the sweep came back like a fingertip across glass. No ridge, no engraving, only the faint hiss of the universe and the smooth curve of natural static. This is not disappointment. It is a measurement that says no carrier here, and in our choir, the rest note counts as music. If someone far away wanted to hum through a comet, we would expect a few simple traces first. A very narrow tone that holds where natural sources are broad. A drift with time that matches a transmitter on a moving platform, not the clean Doppler of a passive rock. Perhaps a repeating pattern that toys with prime numbers or with ratios no plasma prefers to sing. We build receivers to notice such manners without romance. They do not ask, they report, and their logs to date are the kind that let eyelids grow heavier. Scans complete, lines consistent with background, confidence high that nothing spoke above the noise. Radio is not the only ear we keep. Warmth has its own grammar. When sunlight strikes dust and ice, the thermal reply follows a curve we've graphed thousands of times. When a device hides inside and spends power, the curve rises off that page and asks questions. The measurements we have match the old grammar. The orbit, too, reads like a well-copied score. Positions night by night lie on a line, gravity writes, with only the modest slides and nudges that a natural breath of gas explains. If there were pushes beyond that, tiny burns we couldn't attribute to sunlight and vapor, they would have bent the stave, and the pencil would have squeaked in the margin. You asked earlier, lightly, what would be odd enough to wake the room? I keep a small list at hand. If a fragment splits and then fails to follow the clean arithmetic of separation, changing course mid-arc without enough jet thrust to account for the turn, I sit up. If a narrowband tone lifts above the static and persists through a slew, I sit up. If the inner coma refuses to settle into any model that treats dust, ice, sunlight, and spin with their usual patience, I sit up. Odd is not a feeling. It is a residue after models have been fed all their usual meals and still complain of hunger. Suppose something like that appeared. Coordination is a quiet word, but it moves quickly. The people who keep sky ledgers would post a note, and telescopes that were planning to look elsewhere would inhale and turn together. A radio dish would ask for longer runs. An infrared eye would widen its bandpass. An optical camera would start a cadence meant for meteors, not comets. The organizations that wrote urgent calls would push a few buttons, and within hours, a dozen instruments that never share a roof would be listening to the same dot, each in its own register, all of them writing the same timestamps so the parts can be played back as one piece. You would not need to chase rumors. You would watch a calm grid of confirmations fill with marks. Let one long sentence unfold here and soften your jaw as it goes, because nothing in it requires effort. If the sky ever gives even one of those clean anomalies, an unmistakably non-ballistic bend in a fragment's path that holds up under astrometry from multiple sites, or a tone that another dish, then another, hears with the same drift corrections applied, or a thermal climb that stays high after every dust size and phase angle card has been turned over, then the night will brighten methodically, not explosively, and you will see the signatures arrive the way steady rain starts on a tin roof, first as scattered taps, then as a pattern, and only after the pattern stands will anyone add a louder instrument. Until that day, we honor the quiet. The near-silent tone is not emptiness. It is the sound of a great many careful instruments agreeing with one another, of orbits keeping their promises, of spectra laying down familiar names in familiar places, of dishes that know how to be excited, choosing instead to be exact. You are allowed to sleep inside that tone. In fact, it is made for it. I will keep watch with the others, one ear for the faintest hum, one eye on the smooth line of motion, one hand resting on the volume knob so the room stays gentle. And you can let your attention loosen like a hand unclenching around a small stone. Think of this as a lullaby with testable verses. If anything changes, the song will too. If nothing does, the chorus remains what it is, a soft agreement between sky and tools. The screen light cools one shade, and in the dim I can almost hear the halo's hush, a tone thinner than breath, easing towards silence as the room forgets. It was ever noisy. The lab is a hush of small green LEDs, and screens turned low, a night shift quiet that feels like frost on glass. Coffee cools to the side. A plotting window breathes once as coordinates tick forward. Outside the building, the city has exhaled and settled. Inside, the cursor moves like a fingertip, clearing a little fog and revealing what lies beneath. We are past the bend. The visitor is outbound now, and everything it leaves behind on our displays behaves like a veil learning to thin. Numbers are steadier friends than headlines at this hour. Heliocentric distance grows step by step. Sunlight softens by the square, outgassing answers in measured decline. Where the inner coma once felt dense, it now loosens, grains drifting and cooling, the visible haze more like dew than steam. Spectral lines that rose cleanly in August and shouldered higher near late October will, if experience holds, slouch toward the noise floor across the winter. The tail keeps its shape a while longer, but even that drawn-out breath fades as the engine under it quiets. On a second screen, an ephemeris page turns its weeks. Late autumn reacquisition gave us relief. The halo was there, the tail present, the pace obedient to gravity and to the soft shove of gas. December's nights widened the angle and let more telescopes join. January and February tuck the object deeper into dark and farther from our lamps, and the veil grows finer. By March, the path meets the distance where Jupiter circles, not a meeting of bodies, but a crossing of that broad ring in space, a milestone in the cold air. Past that line, the comet is already a memory that still writes, its mist now a penciled smudge tapering across the frame. This traveller is not bound to us. The orbit's shape carries a spare surplus of speed, a hyperbolic excess that keeps the door ajar. We measure it with the ordinary care of night work. Fit positions, subtract the sun's tidy pull, add the tiny tugs that escaping gas can manage, and what remains, still positive, says the veil will not return. Nothing in that sentence is sad. It is simply the climate of interstellar things. They condense under other suns, they wander long, they pass through, they continue. Our role is to meet the mist while it is thick enough to see and to keep our notes dry. In the analysis room, models that were bold in August become modest by design. CO2's earlier lead and water's patchy springs are tested against the afterglow. If perihelion peel back insulating layers, post-bend spectra may show water asserting itself more, tiny islands growing within the haze. If composition was uniform from skin to core, the ratios will hold even as the overall brightness wanes. Either way, the answer is not an announcement. It is a curve, drawn with the patience of winter. Archive scripts run like steady breath. Raw frames become calibrated frames. Calibrated frames assemble into stacks. Stacks turn into maps of emission and colour that, when layered, resemble what a fingertip would trace on a window that has just fogged and cleared, swirls that made sense, while thick, now fading into patterns only careful contrast can find. A long night makes a good librarian, files checked, names cleaned, logs signed, so that months from now anyone can return and understand exactly how the haze was read. Ground-based nights continue as long as the signal justifies effort. Big mirrors will say goodbye more slowly than small ones, but the word will be the same in both registers: thinner. Amateur observers who caught the first afterglow will peel their exposure times longer and watch the histogram lean to the left. Professional queues, always crowded, will make dignified space where they can to squeeze a little more knowledge out of the retreating veil. If a window opens for a sharp eye in orbit to glance again, the image will be more lesson than spectacle. A last, clean look at the geometry of leaving. Let a long sentence carry us softly across the second half of the shift, because the room invites it, and the topic allows it. As the coma relaxes, and the tail slackens, and the bands in the spectrum look more like breath on a cold pane than like paint, we do the slow, satisfying work of comparing beginnings with endings, testing whether the carbon dioxide sheet held its breadth, or whether water's islands grew in the warmth, checking whether the rotation kept its calm cadence, watching for any strayed fleck whose motion refuses to be a simple drift. And while we do, we learn again the oddly restful habit of this job, which is to accept that the clearest understanding often arrives not at the loudest moment, but as the fog lifts and the scene resolves toward less. Beyond March, updates will thin like the object itself. A briefing here, a preprint there, a winter conference slide that pairs the August postcard with a February panel and draws an arrow between them, saying only evolution, which is enough. Somewhere in the same season, a different survey will light its wide field and start catching new faint movers nearer to their first breath of activity. Those, too, will begin as foggy initials on a window, and become, with attention, the legible scripts of other places and other times. In the lab, the cursor moves one last tick. The plot advances by a day, the dot lies where the fit predicted. The residuals are small. The mist metaphor feels literal now, screens dimming like a field when dew dries. You can feel your own jaw loosen as if warmed by a still room. You can feel the shoulders notice gravity and decide it is a friend. Let that stay. The visitor doesn't need us to see it out. We keep the lights low, we save the files, we write one line in a log that values plain speech over flourish, veil thinning, outbound steady, data archived, and the room is quiet now. We have walked a slow arc together, from a faint halo far from the sun to a warmer bend behind glare, and back into open night where details return. Along the way, gentle, instruments kept time, ultraviolet stacks that heard water's echo, infrared maps that found carbon dioxide leading, patient images from Mars, orbit that stitched a gauzy veil, and calm ephemerides that traced an honest path. None of it needed hurry. All of it preferred care. We let small things carry large meaning. A steady rotation, untroubled. A coma that looked fuller when fragments helped. A perihelion hidden, and then an afterglow, measured, without drama. A spacecraft taking notes in November and keeping them safe for later delivery. Ground mirrors reacquiring the traveller and finding it as physics suggested. Brighter, then easing, then thinner still. From here the distance grows. Sunlight softens by the square. Gas relaxes, dust drifts, tails lengthen and fade. In months, the traveller will cross the cold width where Jupiter circles and continue outward for good, a visitor returning to the wide road. What it leaves with us is not spectacle, but a better way to listen. How to trust 3 quiet threads when they agree. How to let a null result be soothing. How to keep our lamps dim enough to see faint things clearly. If your eyes are heavy, that is the right kind of science. The kind that lets sleep arrive while truth keeps working. Thank you for staying with the calm parts, the careful curves, the soft confirmations, the long sentences that make room to breathe. I'll keep a small watch for you as the data finish their slow crossing. You can rest. May your night be easy, your room a little cooler, and your dreams carry the same gentle drift as a comet, leaving light behind it. Good night.